Let's look at the next problem. It's a very classic problem, rope burning problem. So you have two ropes, which each of which take an hour to burn, but either rope has different densities at different points. There's no guarantee of consistency, and different text sections take different time to burn. How do you use these ropes to measure 45 minutes? So this is not that difficult. It's fairly straightforward. So let's say uh, if you for a rope that takes, let's say, n minutes to burn, uh, if you light one end, in that case, given it doesn't matter how that what the density is at each end. If you are going to light uh, both the ends of the rope, you're going to take n by two number of minutes. As simple as that. Because it doesn't matter. It's not even if it's not a symmetric rope. If you're going to light both the ends, it's fairly straightforward that it should take n by 2 minutes, right? So given that approach, or given this piece of information, what we're going to do is we're going to burn both ends of the first rope. We're going to, let's say, burn both ends of the first rope, and we're going to burn only one end of the second rope. It doesn't matter what the density is. Fine. And we know that this rope is going to now burn for 30 minutes, and let this rope burn. And after 30 minutes, when this first rope is completely burnt out, you would have, let's say, a section of the other rope left. It doesn't matter, and 30 minutes would have passed by, right? You know that. And also in this case, I want to point it out that it doesn't matter which end of the rope you're lighting. Let's say this one end of the rope is much more denser than the other, right? I think in the problem is given that the density is not uniform. So ideally the rope would look like this, like good densities in one part, but bad. Like, these are the denser parts in dark. But let's just to give you an intuition, let me say that this much of the rope is more dense than this part of the rope, right? And I'm going to make two copies of this rope. Let's say the very same rope, and yeah, I would, as I said, let's burn the one end of this rope. In the first case, let's say we're putting this end to the test, and the second part is putting this end to the test. Uh, let's say in yellow, whatever it is, that much part is burnt. After 30 minutes, you know that this rope is complete. The first rope is completely burnt out, and let's say if you are going to light this end of the rope, so much of the rope is burnt out. Let's put a number on it, and if you burn this part because it's more dense, let's say only so much of the rope is burnt out. If you want to put a number on it, let's put in some random numbers. Let's say if you light the lighter end, let's say 40% of the rope is burnt out, and in this case, let's say only 20% of the rope is burnt out. Just rough figures, right? But what happens next? The rest 60% of the rope, I think 40 is a fairly lower number given that I'm talking about the lighter than lower dense part of the rope. I think to me it would make sense if I give a better number. Let's say a number that actually matches. Let's say we have, if we're going to burn that end, let's say we're going to be done with 60% of the rope, right? And let's say if we're going to write this end, it's going to be around, let's say, 30%, right? In this case, you have 40% of the rope left. In this case, you have 70% of the rope left. But because in the first case, and now I'm going to say you have to light the other end also. In this case, even though 40% of the rope is left, it's more dense. It's a rope, so it's going to take longer to burn. And in this case, even though 70% of the rope is left, it has a lesser dense part. So this is going to burn faster. All in all, what I'm trying to say is whatever part is left will take probably the equal amount of time to burn. That's all. So it doesn't matter which end of the rope you're lighting up. It's going to take up pretty much the same amount of time. So the final solution to this problem is, you burn both ends of the rope for 30 minutes, and once and one end of the second rope, and once 30 minutes have passed by, you're going to burn the other end also, and this would burn for 15 more minutes. So you have 30 plus 15 equal to 45. This is the solution to the problem.